Hi everyone, I'm Roger Sacilotto. I'm a software architect at Avid. Been working on Fims since the 1.0 specification, and I'm going to be making a presentation of a proposal to add growing content to the Fims API. So this is an implementation direction for incorporating growing content files. These are files that are being recorded so that they're not done. The material is still being added to the file, but you don't necessarily want to wait until the file is done before you can process it. And what we're trying to do is minimize the changes to the existing Fims API so that we can have a lot of compatibility between older and newer service and client versions. So let's look at the problem overview. So today in all the Fims APIs, content is viewed statically. So you have a specification that refers to some content, a file or whatever, and this is all encapsulated inside an essence locator. So you pass that essence locator into a BMO and a request. The service reads that, opens the content, pulls it into the service, writes the output, and then when that's all done, it signals success and returns the new content BMO with a new essence locator back to the client. The output is closed and complete when the service returns, so everything is all done. So the problem with that is that it's very static. You have to wait until the file is done before it's available. So how can we extend this to growing content, or what was the impact of growing content on this? And that is improving the efficiency by processing files as they're being created. So to do that, we have to figure out how to issue a service request before a file is done, because it's not complete, so you can't wait until it's finished. You want to do this before. There's a couple obvious things that you have to think about when doing this. One is that the service can't transcend time. It will still have to wait until the input is finished being created before it can finish a transaction. So that still holds. And the service may have to stall the output. So you can't necessarily rely on a particular bandwidth coming out of that service because there's no guarantee of the input bandwidth. So there might have to be some stalling. So let's give an example of a difference of how this processes can look in terms of the difference between static and growing content. So in the static content space, the input side gets frames. Once it's done, it's passed to a service. The service does its thing, creates an output file. Output file takes a long time. When that's done, and only when that's done, the BMO is returned. It can be passed to another service, and now the second service can process its material, and at the end, it's done. Very linear sequence of operations. So with growing content, as long as the service can handle inputs and outputs, etc., you can create a multi-step pipeline workflow that doesn't have to wait for everything. So we have reading before the thing is over, and we're starting to move frames as they're coming in, and even on and on. So you have multiple overlapping stages in your pipeline, and then they finish, and at the end you have the same result. But you've now taken a lot less time because you've been able to overlap those service operations. So that's the goal of what we're trying to create. So the process of arriving at a proposal for a solution involved discussions about how we can do this. We talked about just handling files on disk. We talked about maybe using service-to-service communications to move essence. We talked about streaming methods. But at the end, we really tried to keep it simple. We figured that the time and effort was going to be limited, and that we would really have more success if we focus on something simple, which is handling files on disk while they're growing. So here's a look at the basics of the proposal. So we said back at the beginning is we want to be able to tell a service that a file or some content is growing, and you can't do that by passing a standard file locator, because the semantics of the existing APIs is that if you see a file locator, you can open it and it's complete. So we were looking for a way to use the kind of existing Essence Locator classes with a wrapper to make the compatibility easier, instead of, for example, using, say, optional attributes like, well, hey, by the way, this Essence Locator is GC enabled. The problem is that they can be ignored, and now your service will treat the growing content as finished content, and there will be errors. So instead, we really put the growing content nature right in the face of the service, and we use a new Essence Locator type, growing content Essence Locator type. Now, services that don't recognize that class, that container, a locator type, will fail the transaction. They will not be able to process it. But for those newer services that do accept growing content, they can open it up, and there's going to be a growing content descriptor. This descriptor will identify features of the growing content, maybe a classification so that you can understand, hey, can I process this or not? It might be a kind of growing nature that I'm not aware of. There can be other parameters that say, you know, for example, MXF, we expect 300 frames per partition. There might even be, as we'll see going forward, additional data about the status of the growing content. And then embedded within the growing content locator, there's the good old-fashioned Essence Locator type that services know how to handle. So the key to interoperability here, older services will not be able to parse these growing content Essence Locator types, therefore should, if they're well written, will fail. The newer services will take them. Also, older clients will not create growing content Essence Locator types, so we don't have to worry about upgrading those. They just won't be able to take advantage of the overlapping workflows. So on the output side, the way that a service can find out if what the status of growing content is by doing a query job. So there is a notification mechanism, but at this point it's defined for either completion or error. So there's no ongoing status updates related to the reply to feature within the API return conventions. So while you're running, the service can respond to a query job request and then insert the growing content Essence Locator in the output. And that's how you get, in the first place, how you get growing content locators. Is the service is writing, and instead of waiting until the end, it then is giving the GC Essence Locators while the service is running. Again, this helps compatibility. Older code won't call query job, and if it did, it wouldn't handle the GC Essence Locator. It will wait until the transaction is complete, so no harm, no foul. If the client can handle the GC Locator, well, now it can pass it on to another service and build that pipeline. So the requirement here, of course, is that new services that are GC enabled must implement the query job interface for this to work. So again, if we're building the pipeline, and to help in processing the growing content, because through experience, one of the difficult aspects of growing content when you're looking at a file is knowing when you hit the end of the file. Is it ever going to grow again? Have you maybe gone too far and you've gone into some maybe footer partition? So having some concrete information that can help the secondary elements of the pipeline work, that information can be embedded inside the GC descriptor as a result of the query job. So you can say, well, I know for a fact that I've created 5,380 frames. So you can depend on that. And check again in 30 seconds, and I'll tell you more. But don't check in any sooner, because I'll just tell you the same thing. So there's a way to get information communicated between the services to make the growing content processing a lot more reliable, remove some of the errors that you get from just being blind and having to discover everything through the file system. And so then when everything is all done, the service at completion will return the standard essence locator type. No more GC data. And now this is consumable by older services. And so there's, again, really trying to get a full compatibility between old and new, not requiring any of the older implementations of either clients or services to have to upgrade. The new clients have to be a little more sophisticated, because if they're calling an older service and they get an error on the they receive an error back when they give a GC essence locator, then they have to realize, well, okay, I'm just going to wait until the transaction's finished and pass the non-GC essence locator and assume that that's going to work. So that's generally the approach we're taking. We still have some work to do on the proposal, so this is in progress. We don't even have a draft yet. We're still settling on the definitions of all the structures, the descriptor, and things like that. And so any questions from the crowd? Did I pay you right? Okay. Thank you very much.